Harness engineering. Building with AI agents is not a coding problem. It is a harness problem. A harness connects power to direction. Without one, the horse runs wild. With one, the horse pulls weight. An OpenAI team started from an empty repository, and over 5 months, 3 engineers shipped 1 million lines of code without writing any of it by hand. Their constraint was absolute: no manually written code. That forced them to invest in the scaffolding, the tools, constraints, documents, and feedback loops that makes agents dependable builders. The claim we will develop is simple. The teams that win will not have the best prompts. They will have the best harness. The 5-month stress test. The numbers matter as a stress test, not a boast. 1 million lines of code, 1,500 pull requests, 3.5 PRs per engineer per day, agent sessions running 6 hours overnight. At this throughput, every hidden weakness is exposed immediately. A missing lint rule produces 50 bad files by morning. A documentation gap sends a dozen agents improvising in different directions. So the real question is, what has to be true around the agent for this volume to be safe? The answer is that rigid architecture, mechanical enforcement, and continuous cleanup, things conventional engineering defers, become early prerequisites, not luxuries. The paradigm shift. The shift in one sentence. We move from typing code to designing the conditions under which code gets produced. The engineer's primary output becomes scaffolding, repository structure, architecture documents, lint rules, observability, quality grades, cleanup cadence. Quality assurance becomes capability design. Instead of reviewing code after the fact, you build the perception infrastructure that lets agents verify their own work. The defining question of the new role is not, how do I code this? But what capability is missing from the environment, and how do I make it legible and enforceable for the agent? Humans steer, agents execute. Humans define taste, direction, boundaries, and accountability. Agents write, test, review, merge, clean up, and repeat. That division only works when the handoff is legible. The repository is the handoff medium. Everything the human decides must be encoded where agents can read it. Architecture documents, lint rules, design specs, core beliefs. Knowledge in Slack or in someone's head is invisible to the agent. If it is invisible, it does not steer. The magic is not replacing judgment. It is reserving human attention for decisions that deserve it, then encoding those decisions so they operate at machine scale. Human taste captured once, enforced forever. The 4 pillars. Identity tells the agent what role it plays. Operating principles and quality standards codified in a core beliefs document. Legibility gives the agent the map, structured documentation, progressive disclosure, architecture guides. The binding constraint on the entire system is how fast human insight can move through this knowledge spiral into the repository. Guardrails define what agents can and cannot change. Layered architecture, dependency rules, custom linters. The principle is containment, not command. Define what must be true, not how to do every step. Entropy management keeps the codebase clean. Doc gardening agents, quality grades, automated cleanup on a daily cadence. Together, these turn agent work from a lucky prompt into an operating system. The meta question. When an agent fails, the tempting question is, what did the model miss? The better question is, what capability was missing from the environment? Maybe the agent lacked context, a convention that lives in someone's head but not in the repo. Maybe it lacked perception. It wrote code but could not see the result. Maybe the boundary was fuzzy. It did not know which layers it could touch. Maybe the test signal was too weak. Every failure is telemetry. The fix is never try harder. It is always a systemic investment, a new tool, a new document, a new constraint. What the agent cannot see does not exist. Knowledge lives in 3 places: people's heads, ephemeral channels like Slack, and the repository. Only the third is real to the agent. A brilliant insight discussed in a meeting does not guide it. A decision agreed on in Slack does not constrain it. If it is not in the repo, the agent improvises, sometimes brilliantly, sometimes expensively. This creates a discipline of continuous knowledge migration. Every alignment, every convention, every decision must flow into the repository. The cognitive medium is the repo itself. The more structured it becomes, the more capable the agent becomes. The monolith versus the map. The team tried one giant instruction file. It failed predictably. Context crowded out the task. Nothing felt important because everything was labeled important. The file rotted instantly, and it could not be verified mechanically. The underlying problem is structural. A monolith tries to command the agent step by step, which prevents it from completing its own feedback loop. The better pattern is a map, a short entry file of about 100 lines that points to deeper sources of truth in a structured documentation directory. Agents do not need more words. They need the right words, close to the work, with clear paths to the next layer of detail. Progressive disclosure. Progressive disclosure gives the agent a small, stable entry point and lets it follow links only when the task demands it. Entry file first, repo map and core constraints. Architecture document next, domains and layers. Then design docs, product specs, or reference materials as needed. Each step deepens context without overwhelming. The agent exercises its own judgment about what to read next. The principle is simple. Do not flood the agent. Give it a trail. Engineering the agent's senses. An agent that writes code but cannot see the result is working blind. The core loop is act, perceive, understand, adjust. If perception is missing, the loop is open. The team built 12 perception channels. For the UI, Chrome DevTools integration, DOM snapshots, screenshots, and video recording. For the runtime, logs via logQL, metrics via promql, traces via traceql. Each in an isolated stack per agent, created fresh per task and destroyed after. With these in place, prompts like ensure startup under 800 milliseconds become tractable. Without them, the agent guesses, and guessing is where expensive weirdness starts. The boring tech principle. The fastest way to make agents reliable is to make the technical surface boring. Simple, stable, well-documented technologies compose cleanly and show up in training data. When a library has opaque behavior, it is often cheaper to re-implement a simpler version in-house, fully visible, fully testable, no surprises. The selection criterion? Can the agent fully understand this from what is in the repository? If not, it is a liability. Boring is not a lack of ambition. Boring is how you reserve ambition for the product instead of the plumbing. Centralized constraints, local autonomy. The platform sets the outer rails, layer boundaries, dependency directions, validation requirements, naming conventions. Inside those rails, agents move fast, picking implementation approaches and completing their loops without waiting for permission. The containing system cannot anticipate all the local variety the agent will face. If it tries to specify every step, it absorbs variety it cannot handle. The concrete example: parse data at the boundary is mandatory, but which library to use is the agent's choice. The what is fixed. The how is free. The rigid domain architecture. Each business domain is divided into fixed layers: types, config, repository, service, runtime, UI. Code flows forward only. Cross-cutting concerns enter through a single gateway called providers. These rules are enforced by custom linters and structural tests, all agent-generated. Dependency violations do not get flagged in review. They do not pass CI. This is the kind of architecture you usually postpone until you have hundreds of engineers. With agents, it is a prerequisite from month one. At agent throughput, 1 day without these rules produces more architectural debt than a human team generates in a month. Mechanical enforcement. The gap between "we have a convention" and "the build fails if you break it" is the gap between a suggestion and a law. With agents, The law is what matters. Custom lint rules, structural tests, and CI checks turn architectural intent into a force the agent cannot ignore. A crucial detail: lint error messages are written to explain what went wrong and how to fix it. The enforcement mechanism is simultaneously a learning channel. In a human workflow, enforcing structured logging or file size limits by lint might feel pedantic. With agents, these become multipliers. Encode once, enforce everywhere. The merge philosophy. At agent speed, ceremonial merge gates become bottlenecks. The team operates with minimal blocking, short-lived PRs, follow-up runs for flakes, corrections cheaper than waiting. This only works when the audit loop is functional, drift is detected continuously, and management enforces structural invariance mechanically. The question shifts from, did a person inspect every line, to, did the system produce enough trustworthy signals to let this change move? Agent-to-agent coordination. Multiple agents working in parallel need clear lanes. Git work trees provide isolation. Each agent gets its own branch, app instance, and observability stack. Agent-to-agent review provides quality. Agents read diffs, check standards, provide feedback, and iterate until all reviewers approve. Agents use standard tools directly: GitHub CLI, local scripts, repository utilities. Coordination is not imposed by a central director. It emerges from the agent's interaction through the review conversation and the merge process. The end-to-end loop. The threshold moment. Given a single prompt, the agent validates the codebase, reproduces a bug, records a video of the failure, implements a fix, validates the fix, records a resolution video, opens a PR, responds to feedback, remediates build failures, escalates only when judgment is required, and merges. Every step is ordinary. The breakthrough is connecting them into a dependable chain. The team is explicit. This depends on their specific scaffolding and should not be assumed to generalize without similar investment. The loop closes because the harness makes it possible. The entropy crisis. High output without cleanup creates a new failure mode: plausible, passing, machine-generated clutter. Agents replicate existing patterns, including suboptimal ones. One hand-rolled helper becomes 10 copies by morning. The code does not break today, but it taxes every future change. The team initially spent 20% of their week on manual cleanup. That did not scale. When the audit loop fails, management constraints lose their grip on actual code. Structural patterns decouple from immediate actions, and the system acts without coherence. The antidote is not slowing down. It is making cleanup part of the definition of done. Continuous garbage collection. Garbage collection becomes a daily habit, not a quarterly rescue. Background agents scan for deviations from golden principles, update quality grades, and open small refactoring PRs, most reviewable in under a minute. A doc gardening agent checks documentation against actual code and fixes discrepancies. Quality grades are tracked over time. The healthiest agent-first codebases will not be the ones that generate the most code. They will be the ones that forget intelligently, continuously pruning what is no longer needed. What agent-generated means? Agent-generated does not mean only code. Behind the code are CI pipelines, release tooling, internal utilities, documentation, evaluation harnesses, review comments, repository management scripts, and dashboard definitions. Even the initial instruction file was agent-written. This is recursion. Agents build the tools that govern how agents work. Humans remain in the loop at a different layer of abstraction, prioritizing, translating feedback, validating outcomes. When we judge an agent-generated system, we should judge the whole production stack, not just the final diff. The scaffolding is the product. In an agent-first world, the scaffolding is not overhead. It is the product surface agents build through. Consider the distribution: 18 tactics on repository organization, 12 on agent perception, 14 on structural enforcement, 16 on audit, knowledge, and legitimation. 60 of 74 tactics are about the environment surrounding the code, not the code itself. The discipline is not in the code, it is in the scaffolding. The binding constraint is the knowledge spiral. How fast human insight becomes repository structure that agents can internalize. The team acknowledges open questions. They do not know how coherence evolves over years. They are still learning where human judgment adds the most leverage. They do not know how the system changes as models improve. But the direction is clear. Better scaffolding creates better code, better review, better cleanup, and better scale. The teams that win will not have the flashiest prompt. They will have the best harness.